Impressively, researchers at Google have just unveiled their latest artificial intelligence breakthrough called UniPi, a universal policy model that's powered by text-guided video generation. And while the idea of creating all-purpose AI agents isn't new, UniPi is pioneering an approach that will revolutionize AI decision-making. But before diving into the four functions of Google's brand new model, how does it stand up against the other heavyweights like GPT, PaLM, Clip, and Flamingo? Firstly, artificial intelligence and machine learning have taken giant strides in recent years, with large language models like GPT-3 and PaLM, and vision models like Clip and Flamingo, leading the pack with their exceptional abilities in zero-shot learning. However, one key challenge with such models is their struggle with environmental diversity during training, meaning the necessity to adapt to diverse state spaces when trained for different tasks or environments. This variance often impedes their ability to learn, transfer knowledge, and generalize across domains. Secondly, when reinforcement learning comes into play, crafting reward functions that apply across diverse environments becomes a considerable challenge. Astoundingly, Google Research's AI team took this multi-sided problem head-on, investigating if these existing tools could be morphed to create a more comprehensive agent, with the focus of their research being text-guided image synthesis. Importantly, the concept involves a planner that accepts an image frame and a text prompt defining the goal, and then generates a trajectory as a video sequence depicting the desired course of action. The actions executed in the video are then extracted by an inverse dynamics model, which is a unique approach because it utilizes the universality of language and video to adapt to new goals and tasks across various environments. Finally, the real magic lies in the following four integral components. Number 1. Trajectory consistency through tiling. Unlike the typical methods of text to video, which often result in videos with a significantly varying underlying environment state, UniPi enforces environment consistency in conditional video synthesis by incorporating the conditioned observed image at each step of the video synthesis. By maintaining the underlying environment state constant, an accurate trajectory planner is built, which is instrumental in designing goal-oriented agents. Number 2. Hierarchical planning. Given the complexity of generating actions in a sophisticated environment, UniPi opts for hierarchical planning. It starts by creating videos at a course level demonstrating the desired agent behavior, and then refines them for greater realism by filling in missing frames and enhancing smoothness. This step-by-step approach ensures each level of detail is achieved, leading to high-quality video output. Number 3. Flexible behavioral modulation. In the planning process, external constraints can be easily incorporated in UniPi to modify the generated plan. By using a prior reflecting the desired limitations based on the properties of the plan, it can guide the plan towards specific states. The flexibility is enabled through the use of a video diffusion algorithm to train the text-conditioned video generation model. Number 4. Task-specific action adaptation. This impressive feature is facilitated by a separate inverse dynamics model that translates video frames into low-level control actions. This model is fed the input frames and text descriptions of current goals, synthesizes the image frames, and generates a sequence of actions to predict future steps. These actions are then executed by an agent using closed-loop control. The promising capabilities of UniPi represent a significant step forward in AI technology. Unlike traditional AI training techniques, UniPi leverages text-guided image synthesis, which enables it to handle diverse tasks across varying environments, making it a potential game-changer in decision-making tasks across domains. Moreover, the prospect of having a single universal policy model that can accommodate various environments and reward functions is quite enticing. This could drastically reduce the resources and time required to train AI models for specific tasks, ushering in an era of efficient and all-encompassing AI agents. However, as with any novel technology, the introduction of UniPi brings along new challenges, and while it solves some long-standing issues with training AI models, Google's new and unique approach may also present unforeseen complications that will need to be addressed as the technology matures into the future. Following the remarkable development of Google's new UniPi tool for enhanced decision-making tasks across diverse domains, the artificial intelligence sphere has taken yet another significant leap with Objaverse XL, which is a database boasting over 10 million 3D objects, marking a monumental advancement in 3D computer vision and generative AI. The creation of this colossal database symbolizes the convergence of AI and 3D technology, and it raises intriguing questions. How did it emerge, and what does it signify for the future of AI? The rapid progression of AI has been propelled by the availability of large amounts of training data. The effectiveness of generative AI systems for text and images largely depends on extensive datasets, primarily derived from the Internet. However, the sector of 3D computer vision and generative AI has trailed behind, largely due to the challenges linked with procuring high-grade 3D data. Objaverse XL is a groundbreaking solution to this data scarcity issue in 3D AI. A consortium of dedicated researchers compiled this extensive collection of over 10 million 3D objects. The database, a tenfold expansion of the original Objaverse dataset unveiled in April, sources data from various online platforms, including Sketchfab, Thingiverse, and Polycam. While Sketchfab claimed the data was gathered without their knowledge or the consent of the artists, the development of Objaverse XL proceeded. This scenario led Sketchfab to implement a no AI tag in February to inhibit such unauthorized data collection. Although this action occurred post facto, utilizing the Objaverse XL dataset, the researchers successfully trained a novel view synthesis model, culminating in the creation of the 0123XL model. This model exhibits impressive zero-shot generalization capabilities and can proficiently handle a wide range of complex modalities, from photorealistic assets and cartoons to drawings and sketches. Initial experiments with Objaverse XL have yielded promising scaling trends for 3D vision tasks, as data scaled from a few thousand to 10 million assets. The researchers are optimistic that an even larger dataset containing billions of objects could further amplify the capabilities of AI models. Objaverse XL is a collective effort from leading institutions in AI research, including the Allen AI Institute, Columbia University, UWCSC, Stability AI, and Caltech. The introduction of Objaverse XL is set to revolutionize the future of AI. The researchers believe that this massive resource will enable substantial advancements in AI for 3D, by significantly enhancing the performance of state-of-the-art models. It opens up new applications in emerging fields such as augmented and virtual reality. In conclusion, the unveiling of Objaverse XL has set a new standard in the AI industry. This resource fills a critical gap in 3D AI data and has the potential to be a game changer